Hello, this is a supplementary video regarding Chapter 9 and confidence intervals, but using statcrunch. So the full Chapter 9 course pack filling out is the first video, and this is a supplementary one, being able to use statcrunch. So I'd like us to jump to page 207. In the full video, we explained how to use one prep Z interval if you're using your calculator, but I want to do example 3 using statcrunch. So example 3 said that there was a random sample of 1,293 random adult Americans. 46% of them believe ghosts are either definitely exist or probably exist. We want to know the true proportion of all adult Americans that believe in ghosts. There are 210 million adults in the US. So in the other video, you filled in what is the sample and its size. So the sample size is n equal to 1293. The population is big N, which is 210 million. We already verified our conditions in the previous video, but it says calculate how many in the sample believe in ghosts. So they told us 46%. So that's 0.46 times the 1,293 in the sample means that, oops, this is X. X is equal to 594.78, but we have to put in an integer, so we're going to go with 595. Okay. Now, letter F says construct a 90% confidence interval for P. So from our gold sheets, we are going to use this formula here. But we're going to go into statcrunch. So statcrunch and go ahead and go there now. So in statcrunch, we're going to go to stat and we're going to proportion stats. And right now we have one sample. So go to one sample and we have with summary. Okay. And you're going to put in the number of successes, which we said was 595, out of the number of observations, which is 1,293. We do not want a hypothesis test. We want to go to the confidence interval, and they wanted us to find a 90%. So we're going to put in 0.90 and then leave this method under standard wild. Everything else is going to be just as it is. So your number of successes is X. The number of observations is N, and then we want the confidence interval and go ahead and hit compute. And there it is. So our lower limit is 0.4374. And the upper limit is 0.4830 when we round it. And then the sample proportion estimate is 0.46. I'm going to show you this on my screen here on my paper. And make sure to write down your steps. So we're in proportion statistics, one sample with summary, and we're choosing a confidence interval. Okay. Remember that your point estimate can be found by taking the average of your upper and your lower bounds, so adding them and dividing by 2. And your margin of error you can find by taking your upper limit and subtracting your p hat, your point estimate. That will give you your margin of error. So I'd also like to look at confidence intervals for population mean. You've watched this for a video as well, but I would like to do a couple of these using the t-distribution for means in statcrunch. So let's go ahead and jump to page 211. Notice on 210, we filled out how to find the critical values. This was chapter 7 stuff, okay? But we don't really need to find that now. The way we're doing it in statcrunch, we don't have to go and find our critical value necessarily. We can just jump to our confidence interval. So let's look at, on page 211, example 3. Okay, so it says researchers at the Basra Maternity and Children's Hospital reported in a 2015 study that from a random sample of 160 child sickle cell anemia patients, their average length of stay in the hospital was 4.34 days with a standard deviation of 2.85 days. You want to construct a 90% confidence interval for the mean length of stay for child sickle cell anemia patients. So we've already verified the conditions in the previous video, but here's where we're going to construct our interval. So you're going to want to write down, we're going to stat and then T stats, T statistics, and then you're going to choose one sample. And the reason we have to choose T statistics and not normal or means, because remember what we talked about in the full video, we have to use a T curve because we are estimating the mean and the standard deviation. So we have to adjust for that. And then you can do with data or with summary. Now this one is with summary because we already know the mean and standard deviation. Okay, so let's go ahead and go to statcrunch. So we're going to stat, and we're going to go down to t-stats, not z-stats, but t-stats in one sample. And the cool thing is we're going to keep coming back here. In chapter 11, we're going to go to 2 sample and we're going to use paired, but for now we're going to 1 sample and with summary. The sample mean for our situation was 4.34 days. The sample standard deviation was 2.85 days, and our sample size was 160. And the cool thing is in chapter 10, we will just be able to come to the same place and use the standard hypothesis test, but we want a confidence interval, so we're going to choose confidence interval, and it was 0.90 for 90%, and then go ahead and hit compute. And there is our confidence interval that we got in the full video. It's the same one, and this is 3.9672, comma 4.7128. So I'm going to go ahead and show you my paper so you can see what I wrote. So here's the formula, and there's our lower limit and our upper limit. Always write the lower limit on the left, the smaller one, and the upper limit on the right. So remember, stat, t-stats, 1 sample with data with summary when you're talking about means. So this is for quantitative data. Okay. Let's do one with data. So let's go ahead and do on page 212. It says an ESPN researcher takes a random sample of NBA players from the 2019-20 season There were actually 514 NBA players in that season. So that's your big N that we needed to verify our requirements, which we did in the full video. But it says, what is the sample and its size? So the sample was 20. And our population is 514. We've already done the requirements, but we're going to construct our confidence interval by putting in the data in StatCrunch. Okay, we're in StatCrunch and we have added in our data here. And we are going to go to stat and t-stats, like we said, one sample, but this time it's with data. So stat, t-stats, one sample with data, and we're choosing var 1, that's where we put it. And all of this is going to stay the same, but we're choosing a confidence interval, 95%, and hit compute, and there it is. And our lower limit should be 199.55, and our upper is 216.35. 199.55 and 216.35. And catch us back for an update for Chapter 10.